This topic for this podcast is related to open pit mine planning, and in particular, the importance of pit phasing. For this discussion, I'm joined online with Gordon Webb, a senior mining engineer with Stone Ontario. Gordon, can you please start off by telling us a bit about yourself and your experience and why you're considered an expert in open pit mine planning?
Sure. Yeah, I've been a mine planning engineer for about 10 years, plus another 5 years in mining geotechnical before that. I've worked in projects all over Canada, US, South America, Australasia, in a wide range of commodities, including copper, gold, nickel, diamond, coal, phosphates, as well as some quarries. I've been involved with projects with numerous different public disclosure standards, including NI 43101, short code and SK 1300, with study levels from conceptual all the way up to feasibility, as well as doing numerous trade-offs and due diligence on other open pit projects.
Thanks, Gord. Can you give us a quick rundown on what is open pit mine planning? What's involved in it?
Sure. Yeah, I think we've covered this in other podcasts, but the basic version is we'll receive a block model from a geologist. Usually we need to make some modifications to those block models to allow it to be appropriate for mine planning. This could be reblocking to mineable sizes, putting in some block value calculations, maybe routing flags. After we've done that, we'll gather technical and economic parameters, often estimates of how much we think the mining cost will be, processing cost, how much it'll cost us to sell the commodities, as well as what prices we'll get for them. Using the block model and the parameters, we will use pit optimization software such as NPVS or Whittle to create a series of nested pit shells. These are mathematical simplified shells. There's no ramps or benches, with optimized pit values inside those shells. And then we vary some of the parameters, typically revenue, up and down, to create basically an onion skin of pit shells sitting one inside the other, with smaller shells targeting the higher value parts of the mine. Once we have those shells, we need to do scheduling, or scheduling and design, which often go hand in hand. To meet all the scheduling parameters, we often need to break the pit into smaller areas, which we're calling phases. These phases can be the starter pits, pushbacks, as well as the ultimate phases. We do our scheduling, and then we'll do cost models on that, assigning cost to equipment, labor, etc. And then that mining costs and revenue will go into a cash flow model. And this is an iterative process at all the different stages. As we see that costs are coming out different from our estimates, we may have to go back and redo the optimization.
So, Gord, you mentioned these phases. Can you give a little more detail on what are these phases and why do we need them?
Sure. Yeah, phases are just contiguous mineable bits of the pit. And as I mentioned, these typically we look at 3 different types of phases. The first one is a starter pit, the very first area that we're mining. And then pushbacks, where we generally expand those starter pits and push it back towards the ultimate pit. And then the ultimate pit is going to be the final pit left in the ground at the end of the mine life. And the main reason for using phases is to allow us to meet all the scheduling targets that we need to meet, as well as often accelerate how quickly we can access ore within the pit and keep the plant fed, and as I said, the scheduling targets and plant targets that we're required to use or that we're
So
looking
obviously,
for.
so obviously they're pretty important. The phase and the initial phase, the one that helps pay back the initial capital, is probably one of the most important. Like, how do we pick these phases?
So within the optimization software, we typically scale the revenue up and down. And if we've assigned a low value to the commodities coming out, if we expect $2,000 an ounce for gold, and we've assigned a value of $500 an ounce, and asked the software to find the best pit, it's going to be a much smaller but very high value pit. So that's typically what we're targeting with our starter pit. And we often look for a couple years of ore feed within the starter pit, and that generally is a good balance between getting the ore out quickly and also having enough mill feed that allows us to begin mining in other phases and get other phases into the ore zones.
No, appreciate it. That's good. It's, if you don't want to go too small, right? Because you won't have that mill feed, and then you'll run out with a big pre-strip. But you also don't want to go too large, because then you'll have all this waste up front, right? And be spending more capital than you need. So how much room is typically required within a phase? Like, how do you pick between phases, like multiple phases?
Yeah, so sizing the phases is, it's a crucial decision, and a lot of times the smaller you can make the phases, the higher theoretical value you'll get. Within the software, if you do what's called a best case scenario, it'll mine the pit basically like onion skins. You take out the little core, and then you're just going to peel off layer by layer. And that's going to result in the highest theoretical value, but typically those phases are not practical. If you look at just taking the ultimate pit and mining top to bottom, one bench at a time, then that's the lowest value pit typically, because they defer waste or defer ore for so long. So what we do is we're looking at some sort of mining width, how much area there is from the high wall to the pit side, or within the bottom of the pit, how much there is from wall to wall, to allow our mining equipment to work efficiently. A lot of times, a starting rule of thumb is kind of the turning circle of a truck plus a swing radius of a shovel will allow you to get a truck in there and do single backup loading. It can just turn its half circle, back up to the shovel, get loaded. You can go a bit smaller than that, but it often requires additional maneuvering of the truck, which lowers productivity. Or if you go wider, you can often double side load with a shovel, which kind of removes spotting time and setup time completely, going from truck to truck.
Yeah, they're all good points. So what are some of the other key challenges when you're actually, now you've picked your phase, now you're designing your phase? Like, what are the key challenges kind of going between your selected phase to your design?
One of the things is just the added complexity of the design from the theoretical model. So anytime you're adding ramps, you're adding geotechnical berms, this changes the slope angle, and this could be different from what you estimated as the overall slope angle in your pit optimization software. So if you need to do a bunch of switchbacks all the way up a wall, then you flattened your wall significantly, you might run out of space between the phases, or between the phase and the ultimate pit. So again, this is a very iterative process in that you've got your ultimate pit, you've got your phases, and you're trying to fit them all in, and you need to maintain mining width for all the phases. Or you could get into scheduling and realize that you're short on ore, and you need to go back and see what you can do to put in additional smaller phases to release that ore a lot quicker. So it's just the iterative design of how all the phases interact with one another.
Yeah, how many phases are usually within a pit, and are they usually fixed sizes, or are they variable?
There's no one answer to this question. Some small pits or pits with very little difference bench to bench, you might be able to mine with a single phase. Some large pits that we've done, they've had 20 plus phases where just to manage all the waste and the ore and all the just the different areas you're going to be mining. Some strip mines in particular, you just mine down your seam, and you mine a small phase, backfill behind you, and carry on to the next phase, and you can have 20 plus phases in a relatively short mine life. For phase sizing, it varies, and usually it starts smaller in the beginning of the mine life. As we mentioned, we like to target kind of 2 years mill feed with a starter phase as a general rule of thumb. And then typically they get a little bit bigger as you're going. You've got more time to set up your pit properly and have phases ready to get into the ore at other times, so they can be slightly larger as you've had more time to prepare them.
So you've now got these phases designed and making sure the access works and whatnot. How do you know if you need more or less phases?
So one of the things is looking at the schedule. If you're struggling to make mill feed, particularly in any of the phases, really, you're running into a bottleneck of not having released enough ore. And in that case, there's a good chance that if you can fit it in, you should be adding another phase at the point where you're running into schedule bottlenecks. These bottlenecks can sometimes be alleviated by changing your fleet, but without any big increases in trucks or shovels, they could also be addressed just by improving your mining sequence, which can often be done with additional phases. If the phases are too small, one thing that you'll often run into is very high vertical advance rates. If you've got a shovel parked within a phase and it's only got 2 weeks worth of material on the bench, then that means you're establishing a new ramp and a new bench every 2 times a month, which is not feasible, not practical. A lot of times vertical advance rates would try and limit to kind of in the 8 to 12 benches a year range. Again, depends on equipment size and lots of other things. But if you're seeing those rates are higher, then you probably want to look at having larger phases. Another flag would be the scheduling software bringing down multiple phases at the same time. It doesn't actually need the additional phases, so it mines 2 phases basically as one.
Yeah, so you mentioned the software. Like, how is this, the software that you're using? How has it improved pit phasing?
So previously, as I mentioned, you use something like Whittle, and you get a bunch of onion skins of pit shells, and as they're not feasible, then you have to manually go in and decide if one phase is how many pit shells you're going to expand and in what direction. You usually don't just go for a full circle around the whole pit. You want to drive the pit to the east or to the west or in one direction, and the software doesn't give you that answer. So it's kind of a manual process, and it's open to interpretation by the mining engineer. With some software like NPBS now, it'll take those phase shells, and you can put in constraints, how many tons you want out of a phase. You can balance ore and waste, and within the block model, it will flag contiguous areas where it can actually put in a phase. And this still needs a lot of input from the mining engineer. You can exclude certain areas until later in the mine life, or force it to mine to certain limits, but without having to do the design of each phase, it allows us to run a lot more reasonable schedules on the pit shells than we might see out of that we had seen previously. So we can look at the different sequences and see how that affects cash flow at a pit shell level. We still, at some point, we'll still need to design those phases, make sure they've got ramps, make sure they've got access, and all the other things that we need from a practical mine design. But it really lets us get a lot closer to practical phases than we have in the past, and try lots of different schedules as needed.
Perfect. No, we'll leave it there. Won't go too much more detail, but thanks a lot for the insights, Gord. If you like to listen to more of these fresh thinking by Snow Nocturo, you'll find them for free on our website, Spotify, Apple Podcasts, Google Podcasts, and most of the other platforms, podcast platforms. If you enjoy this podcast, please subscribe on our YouTube channel so we can keep you up to speed on future releases. Thank you for joining us, and have a good day.